Acha, okay. So in today's class, what we are going to do is we are going to learn the behavior of a convex lens. Okay. So behavior of a convex lens. Okay. Behavior of a convex lens. Acha. Out here in this diagram, this convex lens, unlike mirror, convex lens has a two focus. Okay. Focus number one and focus number two. And this is nothing but twice of focal length. That means if this length is focal length, this entire length is twice of focal length. And if this is focal length, this entire length is twice of focal length. Now see, this lens has two focus unlike a mirror. So one of them is called primary focus and the other one is called secondary focus. But it should be noted that the focal length from head to head is same as focal length from head to head. Okay, and the focal length from head to head is same as focal length from head to head. Okay, so in lenses, two focus are there. One of them is primary focus, and the other one is secondary focus. Okay, primary focus and secondary focus are nothing but the names of two focal points in a convex lens. Okay, now let us learn the behavior of a convex lens for image and object positions. See, suppose object is at infinity. Object is at infinity means the rays are parallel to the lenses. If the rays are parallel to the lenses, what happens is the image gets formed at focus, or the image will get formed at focus. Okay. So when the object is at infinity, the image is at focus. So type of image is real. Okay. Extremely diminished. Extremely diminished means size of image by size of object is equals to 0. Okay, extremely, that means the focal length divided by object distance, infinity, okay, is nothing but focal or image is extremely diminished. Acha, image is real and image is inverted. Acha, in extremely diminished you cannot differentiate, but just inverted, be it mirror or lenses. Whenever object and image are inverted with respect to each other, they are always real. Okay, now see, my object position from infinity moves behind 2s. That means object is coming from infinity to slowly towards the lens. What happens then? See, when the object slides towards, what happens when the object goes from infinity to some distance behind 2f? Okay, now the object is not at infinity, the object is coming towards the lens. What happens? The image goes from here or from focus to the 2f. So from when the object moves from infinity to 2f, image goes from focus to 2f. Image goes from here to here. The nature of image is real, okay, and inverted and diminished. This is it. Diminished meaning the size of image is much lesser than the size of object. Now see what happens when the object moves from behind 2f to 2f, exactly at 2f. Image also gets exactly formed at 2f or 2f on the other side. Okay, so the nature of image is real, inverted, and same size. It is similar to concave mirror. No, convex lens is similar to concave mirror. At concave mirror, whatever function center was performing, the same function out at 2f is performing. Okay, now as I move the image from 2f towards focus, what happens? Hence, when the object goes from 2f towards the focus, so object is somewhere between 2f and focus, the image that gets formed is between focus and infinity. That means as the object slides from 2f to focus, the image slides from this 2f to infinity. So the type of image is nothing but real, inverted. Real images are always inverted, and the third one is enlarged. Enlarged meaning the size of image is much greater than the size of object out here. Okay, the object moves from somewhere this position to the focal length, the image is formed at infinity. Okay, the image is formed at infinity. So the image is, see, at infinity you can neither say it is real or it is imaginary, but just because the pattern of image was being formed out here on this side, so I'm saying the image is formed at, or the image formed is real. Okay, and for infinity you cannot even say inverted or magnified, because infinity, it is, see, real image is always inverted, but for infinity it becomes very dubious things to deal with. Okay, but out here magnification is extremely large. That means if the object was point object, the image would be formed very large. Okay, so magnification out here is very large, very large magnification. Okay, but that's it. Now when we shift our object from focus much towards the lens, so in this case, so suppose I'm shifting my object from this position focus to towards the lens, what happens? Image suddenly shift to the left hand side. So as I'm shifting my object from this position to the lens, what will happen is the image will also shift from focus to the lens. But out here the quality of image is upright. Okay, imaginary. Imaginary means this is virtual image or virtual image. What does virtual image means? Virtual image means the actual refracted ray seems to diverge, but when you look from this side it will appear to converge at this point. Okay, and virtual image is always upright. Okay, upright means the orientation of the object and orientation of the image are same. Point number 3. Acha. Out here the image is diminished. Okay, see, as I chase from head to head, from focus to pole, the image will chase from focus to pole. So at pole the object size should be more or less equals to image size. So this was our behavior of a convex lenses. Now what you're going to learn is behavior of a concave lens. Okay, so how does a concave lens behave? Behavior of a concave lens. So similarly, like convex lenses, even concave lenses has two focus and twice of focus. Twice of focus means nothing but this entire length is twice of this length. That's okay. And the behavior of this concave lens is similar to convex mirror. What happens is when the when the object is at infinity, okay, image starts forming out here, image starts forming at focus. So as the object slides towards the center, no, as the object slides towards the pole, the image will also slide towards the pole. See how it happens. Okay, somewhat like this. Then and gradually the object slided from minus infinity to this point. The image started at focus and slided towards the pole. So as the object goes from infinity to pole, the image will start from focus to pole. Okay, so we'll discuss about the nature of image. Image is always virtual. virtual, upright. Upright means orientation of the object is same as the orientation of image. Upright. For any optical device, be it mirror or lenses. Inverted image means real image, upright image means virtual image. And out here, the image is diminished. Diminished means the size of image is lesser than the size of object. Now what you're going to study is behavior of light rays through lens. Okay. So behavior of light rays through lens. Okay. Suppose two types of lens are there. First one is convex and the second one is concave. You already learned out here it is focus, out here it is twice of focus. Okay, so any parallel ray that passes through convex lens, after refraction it passes through focus. Similarly, out here focus, out here focus, out here twice of focus, and out here also twice of focus. So any parallel ray will diverge, but if we trace back the divergent, it will appear to converge at focus. Okay, similarly, and out here focus, twice of focus, focus, and twice of focus. Out here focus, twice of focus, focus, and twice of focus. Any ray that is passing through the pole, okay, will remain unaffected in case of thin lenses. That means up till now, whenever you're dealing with lens, we're always considering that lens is very thin. Lens is very thin, and both the curvature, both the radius of curvature are more or less same. So out here, whenever anything passes through pole, the rays remains undeviated. Okay. And the third point out here is, suppose this was convex lens, this was concave lens. Okay. Out here this, and out here this one. Focus, focus, twice of focus, and twice of focus. Out here focus, twice of focus, and out here focus, and twice of focus. So any ray that is passing through focus, okay, will become parallel after refraction, and any ray that is passing through focus, out here this is not any ray that is passing through focus, out here it would be any ray that appears to come through focus. That means out here, if the ray is coming out here, okay, after refraction it would become parallel to the optical axis. After refraction it will become parallel to optical axis. Okay, okay, and minimum of 2 rays are required to trace the object and image. But if you know the fundamental of workings of these three principles, the first principle was any ray passing through focus will be parallel. Okay, any ray parallel will pass through focus, and any ray through the pole will remain unaffected for thin lens. So these are the three things we need to know about working of lenses. Now what you're going to learn is lens formula. Okay, so similarly like mirror formula, there is something called lens formula. Suppose there is a convex lens. Okay, out here there is a focus. This side is positive, this side is negative, and out here there is twice of focal length or twice of focal length. See, lens formula also acts for concave lenses. The same formula is also valid for concave lenses. Out here it's focus, out here it's focus, out here it's twice of focus, out here it's twice of focus. Okay, this side is positive, this side is negative, positive, negative. Now see, suppose I have a object out here. Okay, the object distance is given by u from the pole. The image will be formed somewhere around here, given by v from the pole. Up till now I have said that this focus distance and this focus distance are the same. Okay, the lens formula is given by 1 by v minus 1 by u is equals to 1 by f, and this formula is valid for both the lenses. Both the lenses means for both concave lenses and convex lenses. One more thing, while using this formula, the sign convention should always be taken into factor. Asha. Now there is an important terminology that is associated with focus that should be careful with while using the focus. Okay. For convex lenses, when the object is on the negative side, the focus will be taken on the positive side. That means you are taking this focus. Okay. And in concave lenses, when the object is on the negative side, the focus will also be taken on the negative side. Okay. So make sure you note this down. For convex lens, okay, that means for convex lens, when object is negative, focus is positive, and vice versa means when the object is at positive side, focus will be on negative side, and vice versa. And for concave lenses, okay, when the object is on negative, focus is also on negative. When object is negative, focus is also negative, and vice versa. When object is positive, focus is also positive, vice versa. So that means what? That means in convex lenses, okay, focus is always taken to the opposite direction of the lens, okay, opposite to the direction of lens. And in concave lenses, focus is always taken to the side of the lens, same side of the lens. Achha. One more important concept out here. Will this direction change if the medium or the refractive index of the medium is changing? Of course, yes. It depends upon this convention or this formula or this convention depends upon the property of this lens. That means this lens is converging. So out here, f and object will be opposite. Out here, this lens is diverging. Okay, so out here, f and object will be on the same side. But in case of water, in case of material with heavier refractive index, this will behave as a diverging lens. So out here, what will happen? Object and focal length will be treated on the same side. And in denser medium, what will happen? This will behave as a converging lens. So object and focus will be on different side. Understood? So while assuming this formula, I have always assumed that my lens is always operating in air, okay, or lighter medium than the refractive index of the glass material. Acha, few more formulas to note out here. Okay, the first one is the magnification formula. Magnification formula. Now there are two types of magnification. Okay, axial magnification and longitudinal magnification. or lateral magnification and longitudinal magnification. Lateral magnification and longitudinal magnification. Okay. Now, what is lateral magnification? What is longitudinal magnification? See, out here. This is the object, no? This is the object. Okay. So height of object, and this is the image. So height of image. So lateral magnification or longitudinal magnification is nothing but the height of image by height of object. Okay, where hi is the height of image. Height of image means nothing but ab or a dash b dash, and ho is the height of object. Height of object is nothing but a b. Okay, so longitudinal magnification is nothing but height of image by height of object. Height of image by height of object, and that is given by the formula image distance by object distance. That means height of image divided by height of object is nothing but height of image by height of object is nothing but v by u. You can already see that in the derivation. Okay, in the derivation of the lens formula. Okay, now what is longitudinal what is lateral magnification? Lateral magnification is nothing but the, suppose this lens was little bit thicker. Okay, not lens, suppose this object was little bit thicker, so the image will also be little bit thicker. Okay, now say suppose I'm giving thickness of object as TO. Okay, and out here thickness of image as TI. So lateral magnification or M lateral is nothing but thickness of image by thickness of object. Okay, which is also the magnitude of lateral magnification is also v square by u square. Okay, or thickness of image by thickness of object is nothing but, or magnitude of thickness of image by thickness of object is nothing but v square by u square. Now this magnification formula can be also used as velocity. How? Achha. Suppose in the previous slide what I have learned is this was the lens. Okay, this was the object, this was the image, this was the image, this is object, this is image. Okay, so in the previous slide what I've learned is magnification. Magnification means nothing but height of image is this into height of object, and this is thickness of object and thickness of image. So M longitudinal is equals to height of image by height of object is equals to v by u. That means suppose the object was moving with velocity in this direction, or v in lateral direction, vx or v lateral. Okay, or suppose the object was moving in combination of lateral and longitudinal. Let's start with longitudinal. Suppose the object was moving perpendicular to the axis. Okay, this is the velocity of object. Okay, the image will also move perpendicular to the axis, so velocity of image will be somewhere like this. So this longitudinal is also known as, or this formula can be also used for velocity of image by velocity of object. Okay, now instead of moving vertically, okay, suppose this object was moving along the axis. So if the object moves along the axis, if velocity of object is along the axis or lateral velocity, okay, this is lateral velocity of object, then the image will also move in lateral direction, or velocity of image is in same direction as object. Velocity also move in this direction, or velocity lateral of image. So out here, magnification lateral is equals to thickness of image by thickness of object is equals to v square by u square, which is equals to velocity of lateral velocity of image by lateral velocity of object. Understood? So these two formulas or magnification formulas can also be used for determination of velocity. Okay, that means what? That means this velocity and this velocity are related by this magnification formula, and this velocity and this velocity are related by this magnification formula. Okay, so axial velocity are related by lateral magnification formula, and perpendicular to the axis velocity are related by longitudinal magnification formula. Now what happens if the object moves in this direction? Okay, take the component of axial and perpendicular to the axis. Axial components gives formula by this formula, and longitudinal component gives the image formula by longitudinal formula. Understood? Achha. Up till now we have given you the lens formula. Now what we are going to do is the derivation of the lens formula. Derivation of the lens formula. Okay, I'm just deriving it for convex lens. You can do it for concave lens also. Okay, this is f, this is f, this is 2f, this is 2f. So suppose the object was somewhere around here. Okay, the object was somewhere around here. The image will be somewhere around here. Now what do we do is we take two rays. Okay, the first ray goes like this and passes through focus out here. Achha, this was it. Passes through focus out here. Imagine the focus to be out here. Okay, imagine the focus to be out here, and the second ray passes through the pole and at the image. The second ray passes through the pole and at the image. Okay, now we are considering about two triangles out here. Okay, triangle number 1 and triangle number 2. This is our triangle number 1 and this is our triangle number 1. Okay, out here AB. Okay, AB is nothing but the object height. It becomes A dash B dash. Okay, and AP, P is nothing but the image from or distance from object to pole is nothing but PA dash. So from similarity of these two triangles, from similarity of this triangle and this triangle, can I say AB by A dash B dash is equals to AP by A dash P? This side by this side is equals to this side by this side. Why? Because these two triangles are similar. So from the first triangle, or AB by A dash B dash is equals to AP by A dash P or A dash P. This is our equation number 1. Okay, now see, now you are considering two more triangles. This triangle, see, pole is usually out here. Okay, pole is usually at the mid section out here. So just imagine the pole to be out here. Okay, pole to be out here and this ray coming towards the pole. This triangle and this triangle. Okay, so from these two triangle, can I say, Asha, what is this length? This length is nothing but AB. See, these are parallel rays, you know. So this length is equals to this length. So for second triangle, can I say AB by A dash B dash is equals to PF by how much? A dash F or A dash F or F A dash or F A dash. That means what I'm doing out here is this length by this length is equals to this length by this length. Okay, and this is our equation number 2. Now if I compare these two equation, equation number 1 and equation number 2, if I compare these two equation, what will happen? If I compare these two equation, what will happen? AB by A dash B dash, AB by A dash B dash is equals to AP by A dash P and PF by F A dash. So if I compare these two equation, can I say AP by A dash P is equals to PF by F A dash? Okay, this is our main equation which will further analyze out here. Okay, analyze at the bottom. Now out here, see one thing. AP is nothing but the object distance. Okay, AP is nothing but object distance U. Okay, A dash P is nothing but the image distance V. Okay, out here. PF is nothing but the focal length. PF is nothing but focal length. And out here, F A dash is nothing but the, see, this entire distance minus focal length, or V minus F. See, this entire distance is V, no? And this distance is nothing but V minus F. So F dash A is equals to V minus F. Okay, so if we take this equation and substitute all the parameters out here, we get what? AP is nothing but U by A dash P is nothing but, A dash P is not, A dash P is nothing but the V is equals to PF is nothing but P, F focal length, and F dash A is nothing but V minus F. Okay, now if you cross multiply, or 1 by V, or I'm inverting the entire thing. Okay, I'm inverting left hand side and right hand side. V by U is equals to V minus F by F. Okay, if I'm substituting this one, V by U is equals to V by F minus 1, or V by F minus 1. Okay, now I'm dividing the entire thing. I'm dividing both the left hand side and right hand side by V. So 1 by U is equals to 1 by F minus what? 1 by V. Okay, and out here, if I integrate this, 1 by U plus 1 by V is equals to 1 by F. Okay, but out here I have skipped one common detail. What? If I take the thing as positive, or if I take the focus as positive, I must take the image as negative. So if my F is positive, U should be negative. So out here, if F positive, U should be negative. So taking that into convention, minus 1 by U plus 1 by V is equals to 1 by F. So this side is positive, this side is negative. So 1 by V minus 1 by U is equals to 1 by F, and this is the derivation of my lens formula. Okay, what we are going to study next is combination of lens and mirrors. Okay, so combination of lens and mirrors. Okay, so whenever I'm combining any lens or any mirrors, the first thing you must note is, see, while deriving the form factor for lens or deriving the formula for lens maker formula, recall that one I said, no, the image from the first acts as an object for the second. Similarly out here, whenever multiple lenses are there, suppose this is one lens, okay, and this is the other lens, okay, sometimes they can be close together. This one has a focal length of f1, this one has a focal length of f2. If suppose this is one lens and the other lens is separated by d, okay, distance d between them, okay, this one is focal length f1, this one is focal length f2. There might be some other combination. Suppose this one is a lens, okay, this one is a concave mirror, okay, and a lens and a mirror. So whichever combination is it, this one has a focus f1, this one has a focal length f2. So whichever combination I'm using, okay, always note that, okay, object from the first, sorry, image from the first device means lens or mirror, will act as an object, act as an will act as an object for second device, for second lens or mirror, for second lens or for second lens or mirror, or for second device. Acha, how to know first device, second device? See, always trace the path of incident ray. Suppose our object was out here, the incident ray would go through this one, so this one is first device and this one is second device, and this one would form an image out here, okay. Suppose if our object was here, first device, second device, and then our object would form out here. Suppose combination of lens and mirror, so if our object was out here, first device, second device, and then again this ray would bounce back through this one, no, okay, third device, and the image is formed out here, the final image is formed out here, okay. So we'll check few specific scenario, okay. The first scenario is combination of, or first scenario is combination of two lenses, or this scenario, okay. So our first scenario is, okay, out a little bit of correction is left. Image for the first device will act as an object for second device. Second device is combination of of two lenses, two lenses kept without separator, kept without separation. Okay. So first one, this one is the first lens whose focal length is f1, and this one is the second lens whose focal length is f2. Achha. If an object is out here, obj, achha, out here for this lens, for lens 1, for lens 1, I can simply apply 1 by v minus 1 by u is equals to 1 by f, okay, or okay, this is nothing but the u, or 1 by v minus 1 by u, 1 by v is equals to 1 by f plus 1 by u, and 1 by u. This u will become u out here, and this f will become f1. So u f1. Understood this one? Now for lens 2. For lens 2, we can use the same formula, 1 by v minus 1 by u is equals to 1 by f. Okay, and see, this formula is only applicable for thin lens, not thick lens or every type of lens. So out here f became f2. Acha, out here, what is the value of u out here? The value of u is nothing but the value of v out here. Okay, out here e is equals to v from first, or image from the first will act as an object from the second. So 1 by u becomes what? 1 by u becomes 1 by v. So 1 by u becomes nothing but 1 by f1 plus 1 by u. Or if we write this one as 1 by v minus, what is 1 by u? 1 by f1 plus 1 by u is equals to 1 by f2. Okay, so I can similarly write this one, no? Or if I simplify this one, 1 by v minus 1 by f1 minus 1 by u is equals to 1 by f2. Or if I simply write this one, 1 by v minus 1 by u is equals to 1 by f1 plus 1 by f2. Now see, this resembles the mirror formula directly. Sorry, this resembles the lens formula directly, no? 1 by v minus 1 by u is equals to 1 by f equivalent. So if I compare this formula with 1 by v minus 1 by u is equals to 1 by f equivalent. F equivalent is nothing but the equivalent focus of both the lenses. Okay, equivalent focus of both the lenses. If I compare this one, then can I simply say 1 by f equivalent is equals to 1 by f1 plus 1 by f2. So out here, comparing both the equation, comparing both the equation, I can simply say 1 by f equivalent is equals to 1 by f1 plus 1 by f2. Okay. Achha. So our next topic is focal length of two lenses kept at separation d, or focal length of two lenses kept at separation d. What I mean by this is, suppose this is one of the lens 1 of focal length f1. Okay, another lens of focal length f2. Okay, and the lenses are separated by this distance. Okay, we already know for combination of any optical devices, the image from the first device will act as the object for the second device. So for object 1, or so for lens 1, can I simply apply 1 by v minus 1 by u is equals to 1 by f1. Okay, so to find out the focal length, whenever you are finding out the focal length of any combination, okay, the object should be at infinity and the final image after all the device should be at focus. Okay, the initial object, whenever you are finding out the focal length of any combination, the initial object should be at infinity and final image should be at focus. So just write down a note. Okay, for any combination of device, for any combination of device when you are finding out the focal length, when we are finding out the focal length, okay, the initial object should be at infinity and final image should be at focus. The initial object should be at infinity, and final image should be at focus. Okay, initial object should be at infinity and final image should be at focus. So out here, what is this initial object at infinity? So can I simply say 1 by v is equals to 1 by f1? Okay, so the image of first, or v is equals to f1. Okay, but out here image from the first device will be formed at f1, or image from the first lens will be formed at f1. Now see, for second lens, for second lens, I'm applying the same formula. 1 by v minus 1 by u is equals to 1 by f2. So I'm applying the formula for this lens. Okay, so out here u is nothing but this v. Okay, the u out here is nothing but this v. F or v out here is nothing but f equivalent or focal equivalent. Now one more thing, whenever you are applying mirror formula, no, 1 by v minus 1 by u is equals to 1 by f1, we are always applying the formula from the origin taken at pole. So this formula, for this entire formula, the origin is out here. Okay, means whatever image I formed out here, origin, the image is measured from this point. But while to use this formula, I have to take the origin from this point. Okay, so even though the image formed by the first lens is at f1, f1 is measured from this lens, no? So f1 is measured from this lens. Suppose this is the entire length of f1 up till here. Okay, how do I measure the length of f1 from lens 2? So whenever I'm shifting it to the right, suppose this is positive, this is negative, this is positive, this is negative. So whenever, suppose this one was f1 and I'm shifting my origin to by d distance towards the positive side. So whenever I'm doing that, u is equals to out here, u is equals to f1, okay, minus d. Since I'm shifting it towards the right by d distance, it should be minus d. Similarly, if I shift it towards the left, or if I shift it towards the minus side, it would be plus d. Understood? So I can simply write 1 by f equivalent minus 1 by f1 minus d is equals to 1 by f2, or 1 by f equivalent is equals to 1 by f2 plus 1 by f1 minus d. Okay, or 1 by f equivalent is equals to, acha, can I simplify this? f1 minus d plus f2 divided by f2 into f1 minus d, or 1 by f equivalent is equals to f1 plus f2 minus d divided by f2 into f1 minus d. Okay, okay, now let's simplify this. 1 by f equivalent is equals to, acha, f1 by f2. Acha, how do I simplify this? Okay, okay, now to simplify this, okay, I have to take an assumption. What is that assumption? I have to assume that f1 is much greater than d. Okay, so assumption is f1 is much greater than d. Okay, so out here we can simply ignore, or 1 by f equivalent is equals to f1 plus f2 minus d divided by f2 into f1 into 1 minus d by f1. Since f1 is much greater than d, then this tends to 0, or 1 by f equivalent is equals to f1 by plus f2 minus d divided by f2 f1. Okay, if we simplify this formula, 1 by focal equivalent is equals to f1 plus f2 minus d divided by f1 f2, and we simplify 1 by f equivalent is equals to, if I divide this entire equation, it would be nothing but 1 by f2 plus 1 by f1 minus d by f1 f2. So focal length of two lenses separated by distance is given by the formula 1 by f equivalent is equals to 1 by f2 plus 1 by f1 plus 1 by minus d by f1 f2. Okay. Now what we're going to study is we're going to study about focal length of a lens and a mirror. So focal length of a combination of lens and mirror. Okay. Now suppose one of the lens, okay, is joined by one mirror out here. What will happen? Acha, how many devices are there? There are actually three devices. How? First a refraction through lens, then reflection through mirror, and then the final image would be formed again after refraction through the lens. No? So refraction, reflection, then again refraction. So there are three optical devices. Okay. So out here, if we consider this direction to be positive, this direction to be negative. So for lens 1, for device 1 or for lens 1, lens 1 means for first refraction, 1 by v minus 1 by u is equals to 1 by f1, where f1 is the focal length of lens and f2 is the focal length of mirror. That's out here. While calculating the focal length of combination, okay, the initial image is always at infinity and the final image is always at focus. So initial image is at infinity, or 1 by v is equals to 1 by f1. Now for mirror, okay, for mirror I simply apply the mirror formula, 1 by v plus 1 by u is equals to 1 by f2. Out here, focal length of mirror out here is negative. Okay, so it will be depending upon the question, the focal length you want to take positive or negative. So just remember, focal length is negative out here. So while substituting the formula, focal length of the mirror should be taken as negative. Acha. So simply, what is 1 by v? Acha. Let's take the focal length of mirror as negative. Or positive, we'll later substitute in the formula. 1 by v plus what is 1 by u? 1 by u is nothing but this, because the image, so the image of the lens acts as an object for the mirror. So u is nothing but v out here. So 1 by u is equals to 1 by v, and 1 by v is nothing but 1 by f1. So 1 by f1 is equals to 1 by f2, or 1 by v is equals to 1 by f2 minus 1 by f1. Okay, now out here again for lens 2, for lens 2 means after reflection the rays has to again pass through this lens, no? So again for third device, 1 by v minus 1 by u is equals to 1 by minus f1. Okay, acha, out here f2 would be minus, out here f2 is minus. Why is f2 minus? Because concave mirror has focal length in negative direction, or 1 by v is equals to minus 1 by f2 minus 1 by f1. So out here for lens 2, what is u out here? U out here is nothing but v out here. So 1 by u out here is nothing but 1 by v out here. We can simply write 1 by v minus of minus 1 by f2 minus 1 by f1 is equals to minus 1 by f1. Okay, or 1 by v is equals to minus 1 by f1 minus 1 by f1 minus 1 by f2, or 1 by v is equals to minus 2 by f1 minus 1 by f2. The main thing that you have to remember out here is not the formula but the process by which I obtain the formula. Okay, whenever there is a lens and a mirror, we always follow the incident ray. So first device, then reflection is the second device, and the again refraction is the third device. So this entire process is more important than this formula itself. Final image is formed at 1 by v is equals to minus 1 minus 2 by f1 minus 1 by f2, but the process is more important out here. Okay, and we'll learn this process as we begin to solve the problems. Okay, so the f equivalent out here v is nothing but f equivalent. Why? Because the final image is nothing but the equivalent focus, because our initial image or initial object was at infinity, or 1 by f equivalent of the combination is equals to minus 2 by f1 minus 1 by f2. Okay, so the combination of this will act as a mirror. Okay, whenever there is mirror in the system, the combination will always act as a mirror. Combination of lens and mirror always acts as a mirror, with f equivalent is equals to 1 by f equivalent, which is equals to minus 2 by f1 minus 1 by f2. Okay, so this is our f equivalent of the combination. Now this entire thing can be combined to form a mirror which has a focal length of this value. This is the focal length of this value. Let's take the question. Okay, a convex lens of focal length 20 centimeter and a concave lens of b focal length 5 centimeter are kept along the same axis with distance d between them. So what the question is telling is that a convex lens, okay, and a concave lens. The focal length out here is 20. The focal length out here is 5 centimeter. The distance d is between them. Okay. Now, if parallel beam of light falls on A, suppose parallel beam of light falls on A, what will happen? See, it will try to converge, and when it tries to converge, okay, and it becomes parallel after striking with the concave lens. So see this mirror, okay, sorry, see this lens. If nothing was there, or if this lens was not there, where would it strike? Where would the ray converge? The ray would converge at 20 centimeter. The ray would converge at 20 centimeter. Okay. Now see this lens. See this lens. Okay. For which set of rays would this ray become parallel out here? If the set of rays coming towards it are directed towards 5 centimeter from the pole. So if this distance is 5 centimeter, then the rays after refraction would be parallel. So can I say d plus 5 is equals to 20? So from this two diagram, d plus 5 is equals to 20, or d is equals to 20 minus 5 is equals to 50. So our correct answer is 50. Now there is one more way to solve this question, and the way is through formulas. So I'm solving the same question through formula. Okay, by using formula. Acha. Whenever you see a question, the best method is to solve logically by using diagram, okay, or using logic. But once in a while, you must also know the formula method. Okay, by formula method, the main concept is the image from lens 1 will act as an object for lens 2, but that's it. So for convex lens, okay, I can simply say 1 by v minus 1 by u is equals to 1 by 20. Achha, out here this direction is positive, this direction is negative, this direction is positive, this direction is negative. So out here parallel rays means object is at infinity. This parallel rays means object is at infinity, or 1 by v is equals to 1 by 20, or v is equals to 20 centimeter. So the rays would, or this parallel rays would form an image at 20 centimeter from this distance. Okay. Now for concave lens, for concave lens, okay, if I apply the same lens formula, 1 by V minus 1 by U is equals to 1 by F. What is the value of F? 5 centimeter. Okay. Now out here, the image out here would act as an object out here. But this image has a problem. This 20 centimeter is calculated from this origin, no? But while using this formula, I have to calculate the distance from this origin. So how do I convert 20 centimeter from this origin? See, I'm shifting 20 centimeter towards the right, no? So towards the positive. So whenever I'm doing that, what do I do? 20 minus of d. If I'm shifting towards positive, minus of d. So u nu is 20 minus d. Now one more thing. See, this incident ray was coming from negative side, no? So can I say object was kept at negative side? Okay. If the object was kept at negative side, can I say minus of 20 minus d? Why? Because the object is coming from negative side of this lens, or negative side of the concave lens. Okay. Okay. Now simply, if I solve this one, uh, and one more thing, after refraction, the rays become parallel. So out here, final image is formed at infinity. So can I say minus of minus 20 minus d is equals to 1 by 5, or 20 minus d is equals to 5, or 15 is equals to d. Okay, let's look at the question. Okay, a point object is placed at a distance of 60 centimeter from the convex lens of focal length 30 centimeter. So this is a convex lens of focal length 30 centimeter. Okay, and 60 centimeter away from the convex lens is the object. Understood? If a plane mirror is put it perpendicular to the principal axis at a distance 40 centimeter from the lens, this distance is 40 centimeter, the final image is that. So whenever a combination of lens or dual lens, or whenever a combination of optical devices are there, lens mirror or two mirrors or two lenses, the main concept out there is the object. Okay, the image from the first device will act as an object from the second device. So how many types of reflections are there? Refraction or diffraction are there? So to find how many types of reflection or diffraction are there, we have to follow the incident ray. See, incident ray always starts from object. So it will first follow through lens, get refracted through lens, then bounce back through mirror, and then again refract through lens, and then form the image. So there are three instruments, or three times you have to apply the formula. First time diffraction through lens, second time reflection through mirror, and third time again diffraction through lens. So if we apply the formula for first refraction, okay, for first refraction through lens, okay, what is the lens formula? 1 by V minus 1 by U is equals to 1 by F. What's the value of F? F is nothing but 30. Achha, positive or negative? So I assign as a coordinate system, this side plus, this side minus. So if F is plus 30 out here, U is equals to minus 60. So if I do it, 1 by V is equals to 1 by 30 minus of 1 by 60. If you send this 1 by 60 to the right hand side, it becomes minus 1 by 60. Or 1 by V is equals to 1 by 60, or V is equals to 60. So V will form 60 centimeter away from this hole, or away from this distance. So 60 centimeter away from this distance is nothing but this much distance. So 60 centimeter away is somewhere around here. Okay. So if this entire distance is 60 and this is 40, how much is this much? This much is nothing but 20 centimeter. Okay. So this much is 20 centimeter. Okay. Now, see, One more thing you have to remember out here: whenever object and image are formed on the opposite side of the lens, object, image are formed on the opposite side of the lens, the nature of object and image remains same. That means if the object is real, image is real. Okay, in case of lenses, whenever object and image are forming on the opposite side, that means the nature of object and image are same. But in case of mirror, whenever object and image are forming on the opposite side, that means the nature of image changes. That means for mirror, see, for mirror, okay, if object is out here and image is out here, that means object is real and image is virtual. Okay, obj img. Or if image is real, object is virtual. Okay, the nature of object and image are different if they are formed on the different side of the mirror. But in case of lens, okay, in case of lens, if object and image are formed on the different side of the lens, then what happens? They are of the same nature. That means out here, if object is real, image is also real. Okay, and vice versa. Vice versa means in case of mirror, if object is out here, image is out here, both are real. In case of lens, if object is out here, image is out here, one is real and the other one is virtual. So this is the thing that we need to take in mind out here. And when object and image are inverted, it is always opposite in nature, sorry, same in nature. That means for real object and real image, they will always be inverted with respect to each other. Okay, now see, out here is the first image. Out here was the first image. Now this image from this lens will act as an object for this one, and if this acts as an object, this is an this object is nothing but virtual object. Why? Because the object is behind the mirror. Okay, virtual object will form an image at the same distance from the mirror distance. So this distance will be equals to this distance. So the image formed from reflection of the mirror would be at 20 centimeter. Okay. So if this is virtual object, this kind of image would be real. And now this image formed by the reflection due to this mirror will again have to refract from this surface or from this lens. So for third refraction, okay, again we apply 1 by v minus 1 by u is equals to 1 by f. Achha. Out here, this side is negative, this side is positive. Now, as I told you before, okay, in case of convex lenses, image and focus are always on the, sorry, object and focus are all on the opposite side. That means if the object is this side, focus will be on this side. So out here, focus is nothing but minus 30. Okay, what is the image? Sorry, what is the object? Object is nothing but at plus 20. Why plus 20? Because if this entire distance is 40 and this distance is 20, then this distance is nothing but also 20. Okay, so object distance is plus 20 because this side is plus. So we simply apply 1 by v minus 1 by 20 is equals to minus 1 by 30, or 1 by v is equals to 1 by 20 minus 1 by 30, or 1 by v is equals to 30 minus 20, 10 by 30 into 20, 600, or v is equals to 60. Now this v60 is forming from this lens, and v is positive 60. So v is forming somewhere around here. So the final image is formed somewhere around here. Image. Now what kind of object was this? This kind of object was nothing but what? This was virtual object. So this is real image. So out here for this lens, this is real object, okay, and it is formed on the same side of the lens. Real object, then same side the image is formed, so it would be virtual image. So virtual image at 20 centimeter from the mirror. So our correct option is option number D.